Hi, my name is Pablo Fernandez and I'm coming from the University of Sevilla, and I'm here to present the demonstration entitled Automating Infrastructure and Service Audits with Governify. In this presentation, we're going to follow the following points. We're going to see a global overview, then we're going to list the key features of the system. Then we're going to dive into 4 different use cases to show the flexibility of the potential scenarios that could be dealt with this tool. And finally, we're going to see a potential applicability in the context of the EOSC Portal. So first, as a global overview, Governify is a tool that allows to gather evidences and logs from different systems and tools. And based on a definition of a service level agreement, it can generate automatically some dashboards where you can see if the service level agreement are being followed or not. So one of the most interesting things is that Governify is composed by a set of microservices. It is based on a microservice architecture that can be easily deployed and configure. So most of the different components are not used the whole time. So you can pick the different combinations to fit in a specific domain. So that allows you to deploy Governify in different flavors. And we're going to see how variable these flavors could be in the use cases. As key features, we're going to highlight the following. First, the SLA model is highly extensible, so you can use multiple metrics, multiple guarantees, and this model could be also extended in different domains. The second, as we saw, is that a microservice ecosystem is also extensible. All the different microservices provide some APIs, and if you follow the same API, you can extend and create other kinds of microservices that do the same job, but with, for example, with a different technology. It is very easy to deploy. We currently support directly Docker with Docker Compose deployment and also some Kubernetes deployment. And we're working on a Helm deployment for easy deployment in Kubernetes clusters. We would like to highlight that has been used in both public administration and private sector domains. And one of the key features for us is that Governify provides a holistic view of the service governance, because you can use the same tools and model for human-based service or software services. So you can have the same tool and ecosystem and show how the service level agreements for the humans are being followed and for the infrastructure or services are being followed. Finally, we're following an open source model, and you can see the whole list of documentation and different components, source code to extend in our web page. Let's see some use cases to show the variability of the application. First, we're going to see a support service SLA, where some human-based service for IT support can be audit, and we can see how we can apply to that domains. We have applied this scenario in a public administration scenario. Also, the second use case is going to be concerning the software development services, where a team is developing software following the agile methodologies. And we are going to see how this Governify tool can also allow us to see if a team is following the best practices or not. Third, we're going to see how we can govern APIs, RESTful APIs. We have applied this in a public administration and private sector as well, and we can see how can we monitor and audit software services in this case. And also, as software services, the fourth use case is in general infrastructure governance, where we can see either containers or machines or services can be monitored and analyzed if they are following the SLA that should be. The first use case, it is based on a scenario that is present in most public administrations, where you have an official SLA to different providers to the administration. For example, in this case is an SLA related with IT support by human teams. And in this case, the SLA states that 90% of monthly measured. of critical issues should be solved in less than 2 hours. So then in this specific domain, they had an issue management system where the human teams were putting the tickets and following the resolution. So the application in this domain was composed by these 4 different components, by the SLA designer, the SLA registry and computer. We had to create an ad hoc log collector, and we use the SLA reporter that is based on Grafana. So with these 4 components, the only thing we need to do was to create the SLA in our model. So we translate all these natural language SLA into our model, and then the system automatically gather the information from the logs and generate a dashboard to analyze if the SLA is actually been followed or not. And you could also see if in the specific case which kind of issues are not or tickets has been problematic, or which tickets are okay. The second use case is in the context of software development, and in this case we create a list of best practices for agile teams, like for example that one person should only work in one story at a time. And based on the different APIs of the development tools like GitHub or Trello or Pivotal Tracker, Governify was used to gather all these metrics, and the TPAs was transformed into our SLA model. These kind of practices were created into the SLA model, and then we could generate dashboard for the team so you can see the members that are following or not the actual tools. We actually applied this into an educational environment, and this is a joint research with the UC Berkeley, and we could see that it is a very positive impact into the team to see if they are following or not the team practices. The third use case is concerning the APIs, the RESTful APIs governance. Our research group in the University of Seville is pioneered and leads the official service level extension for the Open API specification that is being analyzed by the Open API initiative. And we have currently a final draft to be approved as an official extension for the SLA. And in this case, this specification allows to define limits, quotas, or rates for the different APIs. The interesting thing is that once you have these APIs, if you have your organization with a lot of RESTful APIs, and all of those RESTful APIs are typically behind an API gateway, you could create ad hoc task collectors based on these limits. So you could say that a given API, for example, for free customers should have a specific limit. And you could test whether the API is following or not these kind of limits or quotas. So the Governify application in this case was to create this kind of ad hoc task collectors. And based on the extension, we provide easy to use SLA editor for the APIs. So you could specify the quotas, the rates, or even the costs for the different plans. And automatically, based on the API gateway logs, we could generate whether the SLA is being followed or not. And finally, we can see the infrastructure governance use case. In this case, this is specific cases from the public administration where we have a very big organization that is composed of different sub-organizations with different responsibles for them. And in this case, the whole citizens or different external divisions should access this complex federated infrastructure. In this case, we have support for both Elastic Stack in terms of monitoring, or in case you have a proxy based on Nginx, we have support for those systems in the current ecosystem, but we could also extend to other ones. So in this scenario, you generate an SLA for the infrastructure, like for example, say that no matter what, you should guarantee an average response time of 2 seconds or an availability of more than 95%. So in this case, the application of the Governify allowed the generation of multiple dashboards and gather the information from either the monitoring from Elasticsearch or even the logs from a proxy, and generates global overviews or even specific dashboards for the responsible of each sub-organization. Let's see a specific demo in this case. So in this case, we have a dashboard, so an SLA, a very simple SLA, where you have availability in both high activity and low activity period. You have different levels of availability to guarantee, and the response time, the average response time in high activity or low activity. So based on this simple SLA, you could generate automatically the dashboard for a global overview of the different systems in the different organizations. Like, for example, in this sub-organization, we have some problems, and we can dive into and see a specific view of this organization, where we can see that the different services provided by that organization, some of them are okay and some of them are failing. And even further, you can give a much more detailed dashboard where you can see for specific services, for those specific services, how they perform, and see which are the problematic days for the given service. So as we can see, we can have a lot of applicabilities of the framework. And to finish, I would like to just provide a very high level potential applicability that could be in the EOSC Portal, where this is an old screenshot. It is currently different, but in this case, in the EOSC Portal, you can find the different services. And originally, you could find the documents like the corporate SLA. And the corporate SLA for a given service, for example, says that they define the monthly availability, defined as the ability of the service or service component to fulfill its intended function at a specific time or a calendar month, etc. But this is a document in natural language. So a potential applicability could be to transform this SLA into our model, and we could create ad hoc intended function test collector, so we can see the dashboard we could generate the dashboard and see if they are actually following or not the SLA. And we could also create some templates, so the different services that are in the portal follow the template of SLAs and automatically collect the information to gather. Thank you very much, and I'm open for questions.